Okay guys, our next talk is Hack All the CI by Anna Jan, so enjoy it.
Thank you. My name is Anna-Jan Brouwer. I am a software developer and have been for the last 20 years. Technically a lot longer. I started programming when my father got a Commodore 64 and the cassette tapes were just too expensive, so I drove my bike to the library and got some books with basic source code, and also learned debugging that way because all those books have lots of typos and stuff like that, so you had to fix it with a pencil and yeah, get it back to the library. And sometimes you were lucky, someone else had done the debugging for you already. For the last 21 years I've been working as a programmer, started as a C++ programmer, and currently for the last 3 years I've been working for the Dutch Ministry of Health, Welfare and Sports. Not so much the sports part, but yeah. You might also know me from Badge Team. Since 2017 we've been making a bunch of electronic event badges. Not for this event, but for other events. The Dutch SHA 2017 event, the MCH 2022 event with an FPGA on it. And the 2017 badges are also powering a lot of the lights here, for example, the rainbow tubes and stuff like that. And, well, that's a bit about me. Now, the first lie. I said hack all the CIs, but this talk is pretty much GitHub Actions oriented, and it's not going to be a very deep dive, but just a basic introduction and possibly conversation starter. So, what is CI? The term CI was coined in the early 90s, and technically it is just integrating all the developer's source code to a main branch multiple times a day, or at least at the end of the workday. In that way, you don't get long open branches and big changes that you have to integrate together, but it's a bit of an old term. My version is reducing regression by making sure that changes don't accidentally break other things and assure that API contracts are held. So technically it's just continuous improvement. So why would you use it? Easier co-working, no big changes that have to be merged together, regression prevention, and proving that your code actually works. This is the main DevOpsy way of looking at CI, like an eternal loop that keeps on going. And why would you do continuous deployment? Well, reproducibility. You don't want the artisanal sysadminship of deploying code to a machine by hand by someone with a long beard who is the only one in the office who knows how to, and then gets caught by a bus or something and nobody knows how to deploy the next version. And yeah, it's a way of delivering code that actually works. Which are some of the common platforms? Well, you might know GitLab, GitHub, for the old school Jenkins, and a lot more. There are many more than shown here. So let's do a tiny bit of CI. In this case, I have a bit of Markdown. For the people who don't know Markdown, it's a human readable but also renderable text format. And in this case, you have a header that says, I like CI, and a paragraph that just says, because it helps. So let's put that into GitHub. I make a folder, go there. In the easiest way, create a file.md, then commit it and push it. Well, that's it. So let's add some CI to it. In this case, a GitHub action. In GitHub, you have or create a folder that's called .github, and the workflows folder in that. And it uses YAML files that are really easy to read. So in the most convenient way, I create this Markdown YAML file and push it to the tree. So it looks like this. It has a name, what we're doing, when, so on pushes and on pull requests, and it has a job, in this case lint, which runs on the latest Ubuntu and has 2 steps. First getting the code, then doing the linting. So I push this and linting failed. Well, why? Let's have a look. Yeah, Markdown. Markdown linter says that after a header, you need a empty new line. So Let's, in the most convenient way, add a new line to my file.md. Do some linting, see that it works, and we have a small diff to the side. We commit it and we push it. Yay, it works. So everybody is happy. So that is the basis of CI. So now whenever someone makes a change to that markdown file, you get a response whether or not it is syntactically correct. Not about the content in this case, but just about the syntax. So now let's look at a basic CD example. CD stands for continuous delivery. I think I forgot to mention that, but so let's upload a website to a web server via rsync, which is again super simple. It's a job that is called deploy. It runs on the latest Ubuntu. It has 2 steps. The first is to check it out, and the second is to upload it. And as you might be able to see, there's some hard-coded values in there, like my web server, my username, and a secret. That is something you might want to be able to use. So let's assume that my website repository is also a public repository. We want to use that secret in a way. So let's do nasty and do some social engineering on the side and add a action. So how do we do that? Well, managers like badges. They like progress, they like bars, they like graphs. So let's add a PR that does a bit of code coverage. And in this case, we also want to do that on pull requests. And on that pull request, we want to have a nice badge that says the name of the pull request and the code coverage of the source code there. So we use this simple thing. I haven't included the full action, but it has this nice innocent looking bit where it says echo the pull request title from GitHub and pipe that to the coverage program. Well, that's nice. I get a nice badge that says my awesome PR, and it has a percentage. But what if I call my PR something like the blue box thing? Yeah, then all of a sudden, technically what we're doing is getting a bit of malware from my site and running it. So that might not be something you want happen. And this may sound lame, and I've put a tiny spoiler in the previous slides for people with good memory. This is exactly what happened between January 2021 and April of 2021 with CodeCov, which is not a small bit of Git stuff. It is a small bit of CI stuff. It's a code coverage generator that does testing and gives you nice graphs and nice input, used by 19,000 big companies, including some security companies. And what happened? Some hackers put in a different version of their command line tool that leaked GitHub access tokens. So for the private repositories that it was run on, the hackers got a token so they could easily access that repository, look around, look for more secrets, because usually when it's a non-public repository, people don't want it to be found. People like to have their secrets, mostly companies, or it might be because it was shoddily built and contains other nasty things like other secrets, deployment secrets. So let's do a bit better, and instead of using a direct run where you insert the secret in, or the secret in this case, the other input, namely the pull request title, we set it as an environment variable, which makes it a lot safer to use than to use it inline with a pipe. But how do we get data from GitHub? Because when you set up secrets in GitHub, they will not be logged. It will just be replaced with stars. And even when you base 64 that, it gets replaced by stars. Well, not if you base 64 it twice, or base 32 it, or rot 13, or whatever. Then it gets easy to exfiltrate. But why not do something else? The GitHub API for Actions has a lot of interesting ways to communicate. You can, on a PR, for example, create a comment with a simple line of code. But it gets worse, because most of those CI systems have full connectivity. That script I mentioned, it can just do a HTTP post, it can mail, it can use DNS lookups, whatever, to exfiltrate data in a nice way. So please don't be dumb. Don't use hard-coded credentials in a repository. Don't have CI systems have access to the production data, because CI systems, they need a lot of external parts. For example, if you run a website that's made in PHP with a bit of JavaScript, then you have a lot of NPM stuff. You have a lot of PHP parts. They all need to be checked for ways of leaking your data. So please keep them separate. Don't have your CI have access to any secrets or even worse, production data. Just do better. And in Dutch, when someone's ill, we say beterschap, which literally means get better. So yes, get better. Don't do that shit. Keep your CI and CD separate. Because as I said, CI runs a huge bill of material, has a lot of stuff. It should never contain any secrets. But your content, your continuous delivery system, that does need secrets. It has to find a way to communicate with production servers, for example. Use branch protection. Not everybody should just be able to commit to main. It's very basic. Set up some code owners, and don't run CI on public pull requests automatically. In the past, GitHub Actions would always run automatically for any bit of code that anyone sent you in a PR. That led to a lot of data leakage. Or even better, use separate repositories. At the Ministry of Health, we currently have 75 public repositories, which for Dutch government is immense. And if you want to hear more about that, go to BugBlue's lightning talk. But we also have almost 200, or probably even more than 200, because I don't even have access to all of them, private repositories. So we, for example, on any tagged commit that is pushed to production, we have set a delay of a week and only then publish the data, the code. So in case of stupid mistakes or whatever, we have some time to find them out before we publish the code to the public. So another thing is to do your builds in the CI, but your deploys from a different place. So have a place to store, a secure place, to store those builds and check them before deploying. In short, the takeaway, keep your CI and CD separate, use separate repositories, use branch protection, and just don't be dumb. Any questions? Have I been dumb? Oh yes, yes, I have been dumb. Luckily not with important production stuff, but not in this way. But no, I have sometimes pushed some stuff to Git that I shouldn't have, and then have done some history manipulation and force pushes to really get rid of it from the repository, because just deleting it from Git, it might work for some government organizations. Again, go to BugBlue's talk. But in practice, that doesn't work. Any other questions?
Please wait for a microphone.
Sorry, hello. So
Hello.
GitLab has a similar pipeline mechanism with YAML and everything. I think that GitHub pretty much copied it from them.
Yes,
And
they
is there
did.
anything you know about that? Some vulnerabilities or some exploits or whatever?
As a rule of thumb, the GitLab stuff all runs in Docker, and it mainly has nasty Docker exploitability things that are less common on Azure. I'm not saying that Microsoft Azure is a lot safer, which GitHub runs on, but it's just less common, less looked at, and less exploited at the moment. Most people who run GitLab don't use the hosted GitLab, but run it themselves. And then you have the option of running it either on a VPS or in some Docker containers. And then a lot more security has to be taken in place of not mixing your different environments and getting those credentials or secrets mixed up with environments that run other people's code. Does that answer the question a bit?
Thank you.
You're welcome.
So I have a question. If you can answer it, do you use tools like Sneak in order to, and any other tools for that matter, to check for leaked information, accidentally leaked information? And
yeah, I do. GitHub offers tools for looking at secrets themselves, but I also, for my hobby projects, run a lot of external tools like Sneak with a Y, and some I can't remember the name of, but yes, please use those tools. And also, please set up a linter for your YAML. For GitHub Actions, there's a linter. For GitLab Actions, there's a linter that also looks for malicious patterns. So yes, please use those tools. Anybody else?
Okay, I think that's it. Thank you very much.
You're very welcome.